All right, so let's go. So we're going to be looking at organic chemistry. Now, what I like about this topic, Liz, is that it becomes more familiar with you. It is not as abstract as the others because it ties in. What it does is to reveal to you a lot of the things that bio taught you. So like digestive process, photosynthesis, and those things. It now goes down to the molecular level of these substances and shows you in the format of a chemical reaction what exactly took place. All right, now there's a video that I want you to watch. Now the video is just going to give you an overview of what organic chemistry will look like, so you can kind of set your mind to the change that is going to happen. Now there's a part in it that speaks about skeletal structure. It's not a requirement at this stage, CSEC stage, for you to learn the skeletal structure. However, exposed to the World Wide Web, ladies, and a lot of times when you punch in organic chemistry, let me see if I can zoom, you're going to see some things looking like this. And that image becomes intimidating. It is not if you understand what is going on. So let's go.
Welcome to part 1 of the Organic Chemistry Introduction. I'm Melissa Maribel, your personal tutor, and the most important element for organic chemistry is carbon. Remember, carbon has 4 valence electrons, which means it could have 4 bonds. Knowing this, let's go over the 4 different ways a molecule can be represented. The first way is the typical molecular formula. The second way is the structural formula, which looks like a typical Lewis structure. The third way is called a condensed structural formula. To write this formula, we looked at the structural formula where on the first carbon to the left, there are 3 hydrogens attached. This is why we have CH3. Next, the middle carbon only has 2 hydrogens, so CH2. And the last carbon to the right has 3 hydrogens, so CH3.
This is known as the skeletal formula, ladies. And again, it's not a requirement. However, you will see it. Punch into any search engine right now, and you will see these zigzag structures. All right. And I don't want you to feel intimidated by the image, but just know that that's not a requirement from your syllabus. What we are going to focus on are these 3. A regular molecular formula, just like how you can write NaCl, and you can write H2O, and you can write MgSO4, magnesium sulfate. We're going to write that for organic substances. Organic substances look at structure. And so we're going to start drawing out these formula. We're also going to look at something called a condensed formula. But let's take it from the tippy top, all right? And look at what is this whole thing about organic chemistry. Organic chem, ladies, we're studying carbon compounds. That's the main thing. You're going to talk a lot about carbon, all right? Now, the exceptions, we always have exceptions, is that we're not going to look at the carbonates or the oxides of carbon. So your sodium carbonate, sodium hydrogen carbonate, carbon dioxide, carbon monoxide, these things are not considered organic. All right. The allotropes of carbon, diamond, graphite that we learned about earlier is also not considered organic. So a lot of the times when we think about organic substances, we're thinking of plant and animal derivatives. Coming from a plant, coming from an animal. All right. So these are naturally found in the environment. Now, organic chemistry plays a very important role in life. So living things, because the carbon, bio should have taught you that the main constituents or elements that makes up living things are carbon, hydrogen, and oxygen. All right. So when they talk about food, and they talk about carbohydrates, and they talk about proteins, and they talk about fats and oils and those things. We're talking about carbon compounds, cellulose in plant, carbon compounds. All right. And so it's a vital role in living organisms. And that is why we study it. All right. But then there also, we have skills, but we can also have man-made or synthetic organic substances. So because everything has a chemical formula and can be produced through a chemical reaction, ladies, we can actually recreate these things. All right. And so they are synthetic. So things like plastic. Plastic don't occur naturally in the environment, That's why it don't do so well. And that's why there's this great debate about banning the plastics and the harm that the plastic is doing, because it is not natural. It's man-made. And so these man-made stuff normally have more negative effects on the environment than something that is found naturally. All right. We also look at there's a term that you need to know, which is now hydrocarbon. Organic substances are often termed hydrocarbons, right? And these hydrocarbons will only contain carbon and hydrogen. Now, bear in mind that there are other organic compounds that have other elements in it. So it's not just carbon and hydrogen. So things like carbohydrates, you're most familiar with it. You're talking about like glucose has oxygen in it. Amino acids, we don't get there as yet, but when we start looking at amino acids, you will see that nitrogen plays a big role in it. So the number of organic compounds that exist is a lot. Just look around you. And if you should go hunting just in your home alone, you will find so many examples of things that are organic, right? So let's start with the one that's always a hot topic, methane. All right, some of you say methane, that's quite okay. I say methane. So methane is a hot topic because it is known as a greenhouse gas. And this is something that you know with your bio and your geo and your social studies. Your greenhouse gas, ladies, contributes to global warming. And from your born, you have been hearing, or there have been talks about global warming and the effects of global warming and the ozone layer and it's depleting. That is where it is, right? Now, methane is naturally produced. Okay, it's a natural gas. So we can't stop it from being made because it's natural. However, this is where the change now needs to happen. And it's unfortunate that our country is not pushing towards it more. Your methane gas is very, very good as a fuel. You can use it to generate electricity. You can use it for cooking, domestic cooking. You can use it for heating. So right now, I'm not sure where you are. Where I am is cold. All right, it's unusually cold. We're not used to this. And you could use it to actually, because it burns, and you can use it as a fuel. Now, our homes in Jamaica is not set up like this. But let's think of the other colder countries now, especially, let me tell you where use this a lot. Where you talk about places like Denmark, Greenland, Iceland, those places, they make use of this methane. So what they would do, right? So what is happening in Jamaica right now is that we have a garbage site, big garbage site. The most popular one is Riverton. There are others in each parish. For Kingston and St. Andrew, Riverton City. And it comes up in the news so often. Or Riverton is burning down. Yes, Riverton is burning down because it's producing this nice, rich, natural gas called methane. So when you have the waste starting to decay, this gas is being produced. Unfortunately, we are not tapping in to this resource. All right. If you go to Florida, unlike like Jamaica here, we look outside and we see a hill in front, we see a hill behind. It no matter which parish you're in, you're going to see hills. Florida doesn't have it. However, if you drive along, there is a one hill in Florida, and that hill is actually their garbage disposal. Now, on top of that hill, you will notice that there are a lot of pipes. All right, quite a number of pipes, and that piping system actually collects the methane and then they use it. That is where Jamaica needs to go. So we need to stop complaining and waiting on Riverton to burn down and start trapping this gas and collecting it, because it's very useful. There was a program, some of you will know it on Sundays, at Hilangoli, and they showed a pig farmer in St. Thomas. And what he does, instead of washing away the pig waste, probably dig a hole and wash it away, he doesn't do that. He collects it in something known as a biodigester. Let me see if I can find it. All right. So there's something called a biodigester, and what it does, here we go. So these things are known as biodigesters, ladies. And what it does is to collect the waste, and then it will convert the waste from waste into useful methane. And then you can use it. So some persons like us know where every minute the cooking gas run out in the middle of Sunday dinner, right? That's not happening to him because he has it stored from the pigs that he raises, and he uses it on his farm, right? That is where we need to go. So we're not too big on using or alternative sources of energy. I don't know why. I know there's an expense to the startup, but there are other countries, that is what they are utilizing. All right. Now, let's go back to this one. Ethanoic acid. Ethanoic acid is your common vinegar. And we know Jamaicans love our vinegar, from washing chicken, wiping down counters, wiping the floors, deodorizing, making vinaigrettes for our salads. So that's another organic substance, preserving food. So the pickles that we make. Ethanol is another one, right? And Jamaicans love to talk about their spirits. And the spirits we're talking about is the white rum, right? So ethanol is the main component in this spirit here. So whether it's Ray Nephew, whether it is rum bar rum and whatever else is on the market there, ethanol is the main component. We talk about glucose. So some of us can't run in, and we're not running on sports day, but we have orange and put glucose on it, and we're well eating it or putting it in our hands and eating it, right? Glucose is another organic. You'll also have made glucose from you were young when it comes on to photosynthesis. Now, we're going to look at the formula, that reaction there for photosynthesis. All right. You talk about proteins. You learned about proteins in bio. You learned about the carbohydrates and the digestion. So this is how you learned it. You were told that, okay, enzymes work on them and they break them down. Protein is broken down to amino acids. You know what the chemistry do for you? The chemistry shows you how that breakdown is actually done. And it's the exciting part about it. So you see exactly how and why these proteins are breaking down, how and why these carbohydrates are breaking down, and what the end results are. Nice. We talk about plastic already and the whole banning. We're coming back to it. All right. So carbon has a lot of compounds, but we're focusing on looking at fossil fuel, which is our crude oil, and or carbohydrates or organic acids. We're going to be looking at that, right? But we're not going to focus now on diamond and graphite. Neither we're going to focus on carbon dioxide nor metal carbonates. So we're not going to do those, just these three and a little more. But this is what we're focusing on. All right, so let's put some chemistry to all these natural processes that you have been learning about. And it actually helps you ladies to understand the process a whole lot more. It also helps you to remember the end products. So bio always asks about the end products. It's going to help you in that because you can always write a reaction to get it. All right. So let's talk about carbon a bit. Carbon is unique. And I think you got that notion about carbon being unique. I want to switch books. I think you got that notion about carbon being unique from grade 9. There was always this question, ladies. Miss, what happened to group 4? What about group 4? What happened to carbon? And we weren't really using up the carbon, why? Because carbon now has this unique valence shell with 4 electrons. Yes, silicon has it too, but we're talking more about carbon, right? So it doesn't follow the regular pattern of a group 4 element. It doesn't behave like it's not a metal. And some of the things, it doesn't behave like a non-metal. So it's kind of unique, like your hydrogen. So carbon has 4 bonds because it has 4 electrons on the outer shell. It means that a maximum of 4 bonds can be around a single carbon at any given time, at any one time. You can't have any more than 4, right? And with that 4 bonds, carbon tends to form what is known as a tetrahedral arrangement. So pretty much look like in math when they're talking about pyramids, and what kind of base pyramids are tetrahedral, right? So it's a tetrahedral arrangement that will, so it's a triangular base pyramid. That should be familiar with you because you learned about diamond, and diamond, the head of it was tetrahedral. All right. Now, what else about carbon makes it so unique? How the carbons are bonded. That's what makes it so unique. So with our organic chemistry, we usually have quite a number of carbon atoms. We have simple ones, simple ones like the methane that we just discussed that only has a single carbon. But then we have some extreme where you have thousands, hundreds of carbon atoms in it. And because they can have so many carbon atoms bonded to each other, they form different shapes, so to speak, different structures. So the first structure is known as an unbranched carbon chain, aka straight chain. So you will hear us talk about straight chain carbons quite a number of times. We use the term straight chain. It's the same thing as saying unbranched. So what is happening? You have one carbon linked to another carbon, linked to another carbon, linked to another carbon. And it goes like this. It follows each other in a straight line, right? Now, when we talk about straight, ladies, when we talk about straight, we're not getting too mathematical now, right? Where we talk about 180-degree line flat across. When we talk about straight in chemistry, we are talking about continuous. So I can actually have it looking like this, but notice that my motion, I did not stop. So straight in chemistry means continuous. So we have a continuous flow of carbon atoms. Because think about it. I literally could take this end, and just pull it and straighten it out. It's like, think about your jewelry, your chain. All right. And so once you have one carbon behind the other going on in a series, then it is known as a straight chain. All right. Then we have, here's an example. This is one diagram. You're going to soon learn how to draw these. This is where it becomes exciting. When you start drawing these structures, ladies, no more of the monotonous writing of NaCl. We're going to start drawing. All right, the next one now is when we look at a branched chain. So a branched chain is where you have one hydrogen atom on the straight chain being replaced. So let's look at this example. Here we have the unbranched chain. We have this carbon atom here. And what is going to happen is that it's going to be replaced, and we know about replacement in chemistry, with another group here. And this is known in the video where they spoke about groups, the alkyl groups, right? This is one such example. So just to give you a visual, imagine your chain, but then you decided to add a pendant on it. This pendant is your branch because it comes off the main continuous chain. The main series, it branches off of it. All right. Another way of looking at it, you have a road. So you have the road, but then in the road, we have some turnoffs, some avenues, right? These avenues will be known as your branches. Think of a tree. You have the main tree trunk, and then you start having things coming off the main tree trunk, a branch. All right. Now, the other thing that it can form, we're going to look at that. No, they didn't give you. Right. So that's why I'm using 2 books. The other thing that it can form, ladies, is known as a ringed structure. Here we go. So a ringed structure. Now, I think why the other book left it off is because we don't study ring, but it's good for you to know about it always, right? So a ring structure, as you can see, look on it, just like a ring, a circle. So you can form a ring. A typical example here, it is cyclohexane. It will come up in your reading, but we're not going to study ringed structure. All right, so we are only going to study or branched and or unbranched or straight chain. What else makes carbon unique? Wow, I tell you, there's a lot of things about carbon. Right? Carbon was saying, yes, man, you're saving the best element for last. All right, so let's look at carbon, bonding in carbon. Now, because carbon has 4 possible bonds to exist, carbon can form what are known as single bonds. So we can have single bonds between each carbon. Here we go. A single bond, a single bond, a single bond. So bonds, ladies, for our organic chemistry is represented by straight lines. All right. Remember when we were looking at covalent bonding and we had drawn carbon dioxide. Where are we? We had drawn carbon dioxide or even water or oxygen, and we went like this. Or we have chlorine and we draw the single bond. This is like from grade 9 work, right? These, see them here? These lines represented a bond where you have a pair of electrons, right? Joining. So carbon can form compounds that have single bonds between, whether it's between the carbon or between a carbon and a hydrogen or a carbon and another atom, all right? These single bond compounds are known as saturated compounds. So let's do some reading. It says single bonds can be formed between adjacent carbon atoms, right? In a single bond, a carbon atom shares 1 pair of electrons with another carbon atom. This leaves 3 other electrons per carbon atom available. And you can see why. So I have 1 carbon that is bonded here. Notice that I'm going to have 3, just like what the video was showing. I have 3 more available bonds. So here's an example. In ethane, ethane has a single bond between 2 carbons, carbon number 1. All right, so let me rub off this. Let me zoom it for you. All right, so here we go. We have carbon number 1 and carbon number 2. So only 2 carbons in this chain. But then in between, we have a single bond. However, remember that carbon has a maximum of 4 bonds available, each of them. So what will happen is that each will have, in this scenario, will have 3 available bonds to bond with hydrogen. So that's known as a saturated compound. So a saturated compound only contains single bonds between adjacent carbon atoms. The word saturated means full, ladies, and we know that from English. It means full, maximum. So this carbon atom, or the carbon atoms that are in this compound, will have maximum number of bonds or maximum number of hydrogens surrounded. Next, the next one that we can have is a double bond forming between carbon. So double bonds can form between adjacent carbons. In a double bond, a carbon atom shares 2 pairs of electrons with another carbon atom. This leaves 2 other electrons per carbon. Let's look at the example. All right, here we go. So let's look on it. In this case, we have carbon number 1 and carbon number 2. But what's happening here? In between these carbons, we have a double bond. Now, if we have 2 out of the 4 possible bonds between 2 carbon atoms, we are only going to be left with 2 bonds for the hydrogen atoms. Right? So we can form double bonds. And then there's another bond that was mentioned in the video. So they have now removed it from your syllabus, which is a triple bond. Right? They removed it from your syllabus now, but it's of course I like to make mention of all these things. So carbon can also form a triple bond between a carbon atom. All right, but we're not going to study the triple bond ones. When we have double bonds forming, ladies, the compound is known as an unsaturated compound. All right, and we're going to stop right there. Tomorrow, we're going to continue with something known as functional group. But we're going to stop right there so that you can soak it in. I will post a recording. You ladies need to read your text. You have a physical text, you have textbook online. Do some reading for tomorrow's class.